Hi everyone. Today's class we're going to discuss about relative lowering of vapor pressure, which is the colligative property. What is colligative property? Here is a definition. The properties of solutions which depend on the number of solutes present in a definite amount of solvent, but not the chemical nature of solute. See again. It depends upon the property of a solution is depend upon number of solute, which means how many ions are present in it, how many molecules are present in it. It's about the number of solute, not about the nature, whether it's acidic, base. It doesn't matter about the nature of the solution, right? So it's only about the number of solute particles. Okay. Important colligative properties are relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, osmotic pressure. In today's class, we are going to discuss about relative lowering of vapor pressure. Okay. Let's see. What is relative lowering of vapor pressure? So vapor pressure of a volatile solvent. What is volatile solvent? Which evaporates. For example, when you use sanitizer, you can feel that it evaporates immediately, right? So that is what volatile. So ethanol is a volatile substance. Nail polish remover is a volatile substance, right? So we know what is volatile. Diesel, petrol is a volatile substance, right? So in a volatile substance, a volatile solvent, if you add a non-volatile solute, suppose in ethanol, if you add water, it suppresses the pressure, vapor pressure, right? So it reduces the vapor, right? Volatility, reduces the volatility. So over here, the vapor pressure of a solvent, vapor pressure of the volatile solvent gets lowered when a non-volatile solute is dissolved in it, right? So how you, for example, ethanol is a volatile substance. By adding water, it suppresses the volatility. I mean, the vapor, it decreases the vapor pressure, lowering the vapor pressure, right? Okay. So over here, the relative lowering of vapor pressure. Actually, what? Lowering of vapor pressure is P naught minus P. What is P naught here? Here they mention P naught represents vapor pressure of a pure solvent. So P represents vapor pressure of the solution, right? So this is solvent solution. Suppose if I say ethanol and water, over here solvent is ethanol here, right? And the solution ethanol plus water. So which means lowering of vapor pressure is P naught minus P, right? Suppose relative lowering of vapor pressure, which means P naught minus P by P naught, which means you are dividing with the vapor pressure, I mean pressure of both the substances, I mean solution, right? Okay. So over here, which is equal to relative lowering of vapor pressure is equal to mole fraction. So that means how many particles involved in it, right? Yeah, we are going to see how to measure the relative lowering of vapor pressure. See this apparatus setup. This is what called Oswald Walker's apparatus for measuring relative lowering of vapor pressure. So here there are set of 3 bulbs over here which contain solution A. Solution A. And there are another 3 bulbs which contain solvent B. Okay. And over here we have a U-shaped tubes which is filled with calcium chloride. What is the use of calcium chloride? When you pass a hot air through this, the air will absorb the vapor over here and which reaches solvent B. There it gets more vapor from the solvent B and the air gets saturated, which means no more substances can dissolve in it. So the air gets saturated, and the saturated air reaches the weight calcium chloride tubes. What happens here? These calcium chloride tubes absorb the moistureness, I mean the vapor which the air has, okay, which absorbs, and you get dry air back over here. So by weighing the calcium chloride tube, you will get the mass now increased, right? So by subtracting the initial and final values, you get the mass of solution and mass of solvent, right? I mean the vapor pressure of these. Okay, yeah. Let's see how to calculate. Okay. Over here, what is that loss in the mass of bulbs of set A containing solutions, which is proportional to P, and loss in the mass of bulbs of set B, which is solvent, proportional to P naught minus P. So which means what you are calculating here, gain in the mass of U tube, the calcium chloride, that tube contains P naught. So how to calculate this? Loss in the mass of solvent bulb by gain in the mass of calcium chloride tube. So in solvent, what is the loss? By gain in calcium chloride. Okay, so which means loss in mass of solvent by loss in mass of solution bulb plus loss in mass of solvent bulb, okay, together, because both are there in calcium chloride, right? So by doing this, you will get the lowering, relative lowering vapor pressure. Okay. See here, while calculating this, we saw that this is equal to mole fraction. So what is mole fraction then? X solute is what? N by N plus N. So what is this N called? A small n denotes moles. Moles means what? Mass by molar mass, which gives us moles, right? But what is this capital N? That is also same, but the small n represents mass of solute by molecular mass of solute, and the capital N denotes mass of a solvent by molecular mass of the solvent, which means moles of the solute is small n, and capital N denotes moles of the solvent, right? Which means N is equal to W by M, and N is equal to capital W by capital M, right? W by M dash. So over here, if you see, that is what we just substituted this. N is W by M, and capital N is mass of solvent by molecular mass of solvent, and small n denotes the solute, mole of solute. Okay, so just we substituted this. So over here, actually this is a very dilute solution, right? Very less vapor dissolved in it. So very dilute solution. So we cannot calculate much the moles, which is number of particles which is present in it, which means over here we mentioned N plus N, which means the number of moles is very less. That means N is very less than the mass of, moles of the solvent, right? So we, instead of saying N plus N, we can say N. This is approximately more or less this, right? So easily we just say N, small n by capital N, which denotes solute by solvent, right? Okay. So again, they've substituted with N with mass of solute by molar mass of solute by mass of solvent by molar mass of solvent, so that you get it. Okay, and this is how we get find the relative lowering of vapor pressure. So we need the mass of the thing. So M dash, we need to find the M dash, mass of the solute. To find the mass of the solute, we rearrange this. So whatever you want, according to the question, you have to rearrange the formula. So first check By seeing the question, first check what is there, what are all the data are given, and what is missing. According to that, you have to rearrange the formula, right? Okay. Let's see a question. The vapor pressure of water at 298 Kelvin is 23.75 mm mercury. Calculate the vapor pressure at the same temperature over 5% aqueous solution of urea. Okay, over here urea's formula is given. So what are all the data given here? Urea 5%, which means 5% in the sense 5 gram in 100 grams. So mass of solute, mass of urea 5 gram, mass of solvent is water, vapor pressure of water they mentioned, which is urea in water. So water 95 gram. So 5 gram urea, 95 gram water. So vapor pressure also given 23.75, and molecular mass of water we can calculate. Molecular mass is 18 since H2O. And the molecular mass of solute, again formula has given, so you have to find the sum of all the mass numbers, so you'll get 60, right? Now how will you find the vapor pressure of the solution? So now rearrange the formula. So P naught minus P by P naught is equal to N by N plus N. So which is what? W by the M dash, which is mass of the solute by molar mass of the solute, and mass of the solvent by molar mass of the solvent, plus mass of the solute plus molar mass of the solute. We have everything, right? Except this P, we have everything. We have pressure, and the only P we have to find, only the pressure we have to find here. Otherwise, all the data we have here, right? So by substituting this, by calculating this, you'll get the pressure of P, right? So that means the vapor pressure of the given solution at 298 Kelvin is 23.37 mm mercury. Got it? Hope you understood, children. Tata,